Today, we're going to talk about reactive oxygen species and oxidative stress and its primary relation into human disease. Hi, my name is Sam Shepherd, and we've had such positive response from the use of the ValAsta, but people's inflammatory responses have been greatly reduced, and I've been asked, why is that happening? So today, we're going to run through what the impact is of the ValAsta on reactive oxygen species and on the oxidative stress that's causing the inflammatory response in the human body. These are the topics I'm going to discuss. What is oxidative stress? What is ROS, reactive oxygen species? What is the impact of reactive oxygen species on human disease? And how can reactive oxygen species, or ROS, be managed and reduced? Oxidative stress is nothing more than when a cell gets damaged and your body responds to that cell damage. One of the byproducts of metabolizing that debris field, or the debris from that, is the generation of free radicals. So this can be caused from emotional stress, where you have hormonal release, the byproducts of the metabolism of those hormones, whether they're adrenaline or steroids or even sex hormones like testosterone, estrogen, progesterone. The byproducts of those are free radicals, and I'm going to detail what those free radicals are. They form what's called reactive oxygen species. This is an oxygen-derived free radical, and I'm going to go through what chemically makes that up. It might get a little boring when we start talking about the chemistry, but it's very important in how reactive and how devastating these free radicals can be on the DNA for cancer, rheumatoid arthritis, lupus. There's several of those out there. This is the first diagram that shows pretty much what's going on. This here is the free radical. And typically what happens in each atom of oxygen, you want to have a paired set of electrons. Sometimes there's one missing. So just imagine that that one is blocked out. It has a space for an extra electron. Makes this extremely reactive. This free radical can dive into the DNA, the RNA, it can cross the phospholipid membrane of the cell. It's free to go anywhere it wants inside your body to wreak havoc. What an antioxidant does is it has the ability, because it has excess electrons, to donate one of those and totally interrupt the inflammation response coming from these free radicals. Here's a list of some of the reactive oxygen species. Some of them are radicals, some of them are non-radicals. But I'm going to focus primarily on the radicals here. The superoxide, which is an O2 molecule with an excess electron, highly reactive, reacts in milliseconds with any organic molecule that has a functional group. Hydroxyl group, which is an OH group. This is extremely reactive. Peroxyl groups, byproducts of decomposition of cellular debris, hormones. Same with the alkoxyl groups and the hydroperoxyl groups. Here's some that are non-radicals, but just as dangerous. Hydrogen peroxide. This is a very interesting non-radical in that when you drink alcohol, for example, to metabolize that alcohol in your liver, you produce peroxides. And it takes peroxisomes, which are enzymes inside the body, to neutralize that, because this is highly toxic. This is what causes fatty liver, cirrhosis of the liver, when you no longer have peroxisomes that can neutralize, or antioxidants that can neutralize the formation of hydrogen peroxide. Hypochlorous acid, this is bleach type products, chlorinated products. Ozone, UV light stimulation from the sun. When the UV light hits your skin, the oxygen in your dermis or epidermis is converted into ozone. Ozone is highly reactive, and this is oftentimes what leads to the formation of melanoma. Singlet oxygen, another highly reactive product, and peroxynitrites, which are compounds that can react with the carboxylic groups and the amine groups of most proteins and fatty acids. Here's just a basic diagram to show where the unpaired electrons are, what makes these molecules so active. It causes over 90% of all non-bacterial, non-viral, and non-parasitic diseases. So all your inflammation, your lupus, diabetes, cancer, dementia, also it appears to be a result from the use of these, or the reaction with these reactive oxygen species. Where do they come from? UV, sunlight generates ozone, pollution, heavy metals, nitrates in the air. You can get carbon monoxide, for example. You can get other oxidation products from the pollution. In the cigarette smoking, what we found was it was primarily carbon monoxide is what was causing the stress, the oxidative stress issues in the bloodstream. Emotional stress. Anytime that you're secreting a fight or flight reflex that generates a hormone or a steroid, that steroid has to be metabolized at one point or another in the body. When it's metabolized, the byproduct is a free radical. And now you can see what this little fella can do. Causes cancer, aging, heart attack, diabetes, dementia, that's dermatitis, dementia, Alzheimer's, Parkinson's are all related down here at the bottom also. And what we're finding more and more is that in Alzheimer's, for example, the beta amyloid protein that actually forms the plaques in the brain, those proteins are being unfolded or misfolded from their original condition as a result of exposure to these reactive oxygen species. Here's just some information that you may have. It causes DNA mutation for cancer risk, causes proteins to misfold, causes tissue inflammation resulting in arthritis, lupus, dementia, hair loss, causes over 92% of non-bacterial, non-viral, non-parasitic disease in humans. The other advantage is that when you are exposed to a bacteria, a virus, or a parasite, the product of decomposition of your own immune system attacking these invaders is that they will secondarily produce reactive oxygen species. That's why, although it causes 92% of non-bacterial, it will also reduce the effects of these diseases by eliminating those reactive oxygen species that will tend to auto-accumulate in your body, generating arthritis, joint pain, a lot of other things that come with exposure to bacteria, viruses, or parasites. This is sort of developed this. This is a human disease tree, and typical medicine treats the tips of these branches. So here's an arthritis branch, a fibromyalgia, cardiovascular, cancer, lupus, diabetes, MS, Alzheimer's, and amyloidosis diseases. We treat the effects. It turns out that all of these diseases seem to originate from reactive oxygen species. If we treat this, what we find is that even if we use an antioxidant to treat cancer, we find a huge favorable beneficial effect on arthritis. So by treating the ROS, we can effectively talk about curing all of these other diseases simultaneously. This is a whole paradigm shift in the way that medicine currently is being taught. This is a list of just some of the diseases caused by free radicals or reactive oxygen species. This is a very good slide. It shows that it's over the entire body. It is a whole system effect. And the things that if you were to manage or control the reactive oxygen species, all of these would be somewhat reduced. This is one I'm going to talk about a little bit as to why the ROS works on cancer. There's several reasons, but one of the questions that I get frequently is why does cancer only eat sugar and normal cells require oxygen? The reason is because cancer cells are all anaerobic, which means they're glucose dependent. The normal cells are aerobic, which means they're oxygen dependent. So you might think, okay, if I starve the cancer cell by not eating sugar, then the cancer cell should die and the normal cells should be okay. Well, it turns out that's not the case. Anaerobic cells have 10 to 100 times more insulin receptors on its surface than a normal cell. So, if you truly start cutting sugar back, the anaerobic cells will always be fed at the expense of the normal cells. The normal cells will tend to die. And that's why on you lose appetite, you begin to lose body weight. The cancer cells are all fat, dumb, and happy. The normal cells are the ones that are dying due to lack of glucose. So cutting sugar out of your diet is not going to have an effect on cancer cells. What stops reactive oxygen species? Antioxidants and free radical scavengers. These are chemical compounds found in nature, and the problem that we have today is, as a human race, we don't eat enough of these. These are fruits and vegetables, very large quantities in some cases. ROS has a tendency to accumulate with age. So as you get older, two things are happening. You're generating more ROS, but the lysosomes, the peroxisomes, the enzymes that actually would be internally produced to control these ROS are not being produced at the same rate as if you were 20 or 25 years old. So you have two things going against you as you age. One is the generation of more ROS and the reduction in the elimination of the ROS. Both of those things auto-accelerate the aging process and the drive towards disease. Here's an example of some of the antioxidants that exist in nature. It's, for example, milk chocolate. This is what's called an ORAC score. It stands for oxygen radical adsorption capacity. And it's the rate at which these materials can actually stop the autocatalytic effect of reactive oxygen species. So when this donates an electron to a free radical, this does not become a free radical. So it stops that whole process. Now you can see here, Akiberry, which is one that's being promoted, has 102,000. Turmeric, which is curcumin, 127,000. Ground cloves spice is one of the highest ones. This is the strongest antioxidant on the planet that exists in nature. You can see why astaxanthin, which is what is in the ValAsta, works so well as a free radical scavenger. And this is why we're seeing such an effect, a benefit with arthritis, where people are coming off of Humira and other arthritis drugs simply by taking this. This effect happens within 3 to 7 days. You begin to see positive results. So it is a highly reactive antioxidant. No known side effects to date. Completely natural. These are some of the lifestyle issues that we have that generate reactive oxygen species. And one of the things that I want to talk about is to how these reactive oxygen species actually get to the inflammatory response. And I just put something here on the board. And this is all researchable. But you can see here I've written ROS activates inflammasomes. Inflammasomes are the initial point of the inflammatory pathway. But inflammasomes have the ability to activate interleukin-1 beta, which is an inflammatory chemokine. It's the quarterback that sort of instructs all the cells how to act, and that generates the pathway that causes inflammation. So it starts here and ends with arthritis, lupus, cancer, diabetes. We think fibromyalgia. There's several of these types of diseases on that disease tree I showed earlier that can be stopped simply by stopping this. And with that, I'm going to invite folks to contact us if they have any questions, and I hope this has been helpful. Thank you for your time.